Hi children, in this video we are going to have a series of sessions based on electrolytic cells and electrolysis. We were learning about reactivity series and electrochemistry. So let's recall about electrochemistry and the electrochemical cell that we studied earlier. And electrochemistry is the study of chemical reactions that produce electrical effects. One of its example is galvanic cell. The reaction takes place in a galvanic cell is spontaneous. That means the process takes place on its own. It doesn't need an external influence. Galvanic cell convert chemical energy into electrical energy. The flow of electron is from anode to cathode. Today we will learn about another electrochemical cell, that is electrolytic cell and its principle of working. Here we go. We can start with the definition of electrolytic cell. It is an electrochemical cell that uses electricity for a non-spontaneous redox reaction to occur. Non-spontaneous means it needs an external influence for the reaction to occur. In an electrolytic cell, electrical energy is converted into chemical energy through a process called electrolysis. The process in an electrolytic cell are the reverse of those in a galvanic cell. It is most often used to decompose the chemical compounds in a process called electrolysis. In Greek, the word lysis means separate or break up. So we can say that electrolysis is the process of separating chemical components in a compound using electricity. Electrolysis of water is a chemical reaction using electrical energy. Haven't you learned about this reaction in lower classes? Do you know what are the substances obtained when electricity is passed through this water? Water decomposes into hydrogen and oxygen when electricity is passed through it. Do such type of chemical reactions occur when electricity is passed through metals? Let's see. An electrolytic cell consists of two electrodes and an electrolyte. These two electrodes are connected to a battery. An electrode is a substance which passes electricity to the electrolyte. It can either be the metal plate, wires, or graphite rod. The substance which conduct electricity in molten state or in aqueous solutions and undergo chemical change is called an electrolyte. Acids, alkalis, and salt are electrolytes in their molten state or in aqueous solutions. The process of chemical change taking place in an electrolyte by passing electricity is known as electrolysis. That is, the electrolyte will undergo dissociation as positively charged cations and negatively charged anions. In molten state or in aqueous solution, ions of the electrolytes can move freely. These ions are responsible for the conduction of electricity by the electrolyte. It was Michael Faraday who gave a scientific explanation for electrolysis for the first time. The electrode which is connected to the positive terminal of the battery is the anode. Anions are attracted towards the positive charged electrode. The electrode which is connected to the negative terminal is the cathode, and cations are attracted towards the cathode. Since the positive electrode is anode in an electrolytic cell, the process takes place will be oxidation, and reduction takes place at a negative electrode cathode. Okay students, let's recall. Today we learned about electrolytic cell. An electrolytic cell is an electrochemical cell that converts electrical energy into chemical energy. An electrolytic cell consists of two electrodes and an electrolyte. Electrodes are substances which pass electricity to the electrolyte. And electrolytes are substances which conduct electricity either in molten state or in aqueous solution. During electrolysis, the positive ions in an electrolyte, that is cations, move towards the negative electrode cathode, and the negative ions, anions, are attracted towards the positive electrode anode. The process takes place at the positive electrode anode is oxidation, and the process takes place at the negative electrode cathode is reduction. In the next video, we will study the electrolysis of molten and aqueous compounds. Thank you.